This is momentum example problem number 4, and we've got this gentleman by the name of Flash performing a high-speed camera experiment. He shoots a pellet gun and shoots a pellet into a pumpkin. When he does that, the 1 gram pellet travels at 100 meters per second till it hits the edge of the pumpkin. So let's draw a picture. Here's the edge of the pumpkin itself, and we'll put our little squiggly marks here. And the pellet initially is traveling towards the pumpkin, and when it hits the pumpkin it's going 100 meters per second. So that would be our original velocity of 100 meters per second. Once it gets to the pumpkin, it then travels into the pumpkin and is slowed down until the speed of that pellet, final speed, is equal to 0 meters per second. They tell us that the distance that it travels from the very outside of the pumpkin to where the pellet stops, this distance is 2 centimeters. So we'll write that down here. That's our distance. And they tell us that the mass of that pellet is equal to 1.0 grams. If you remember from before, we've got some problems here. We need to make sure that everything is in kilograms, meters, and seconds. So the first thing we need to do is let's take that 1.0 gram pellet and let's convert it into kilograms. We know that 1 gram, we've got 1,000 grams, and every kilogram, the grams will cross off. We can move the kilograms up to the top. So that would be equal to 0.001 kilograms. So far we've got our kilograms correct. The next problem we have is our distance is 2 centimeters. We need to convert that to meters. There's 100 centimeters in every meter. So we cross off the centimeters, and that will give us 0.02 meters because the meters will then move up to the top when you do your division. To find the time that it takes for that pellet to travel from here to here, first thing we need to do is let's figure out what the average velocity of the pellet is as it travels into the pumpkin straight across. In order to find the average velocity, we're going to take the final velocity, going to add the original velocity, and then we'll divide that by 2. Our final velocity from our picture was 0 meters per second. Our original velocity is 100 meters per second. We're going to divide that by 2. And when we do our math, we should end up with an average velocity of 50 meters per second. So that's the very first part of this problem. The next part of the problem will help us actually find the time. Let's go ahead and clear the board, and let's find the time. In order to find the time, we're going to say that the average speed from the previous part was 50 meters per second. We also know that the distance in the correct units was 0.02 meters, and we did that before. For average velocity, that would be the distance that it traveled divided by the time that it took. We can now plug all of our values in. 50 meters per second was our average velocity. 0.02 meters was our distance. We're going to divide that by time. If you rearrange the equation, you can cross multiply. We know that this side, this is 1 on the bottom. So we would have t on this side would be equal to 0.02 meters divided by 50 meters per second. And when you calculate the time, you'll get 0.0004 seconds. For this one, I'd put it into scientific notation. To do that, we just move the decimal over 1, 2, 3, 4 spots. Because we're making a smaller number into scientific notation, we'll say it's 4 times 10 to the negative 4th seconds. And we are now finished with example problem number 4 for momentum.